Hi everyone, this is Mary and welcome to Super STEAM at Home Junior Edition. Today we're going to do some Halloween science and learn a little bit about chemistry and about how a solution is formed. We'll do that by doing an experiment to see which of 3 different liquids, vinegar, cooking oil, or water, does the best job of dissolving some candy pumpkins. Now when we say dissolve, what do you think we mean? When something dissolves, we're talking about a solid that gets put into a liquid, and then the solid turns into a liquid too. So we don't see it anymore as a solid. It's another liquid that's blended in with that original liquid. So that's what we mean when we say something dissolves. Okay? And we're going to find out more about that through our experiment. So let me show you what you got in your kits. You got 3 clear plastic cups and some candy pumpkins, and also a data sheet where you're going to keep track of your prediction and also your observations as these pumpkins sit in their liquids for a while. Okay, but you're going to have to add some things from home as well. It's good to have some paper towels, some kind of a timer. You can use a kitchen timer or a timer on a phone. It's good to have a marker and maybe some paper, a spoon, and some measuring cups. Now you can use just one measuring cup and wash it out in between the different liquids, or you can use separate measuring cups. Just to save some time for my recording here, I use separate ones for the 3 different liquids. Okay, the first thing we're going to want to do is mark our cups so we can tell what liquid is in what cup. So I'm going to write vinegar on my first cup here, and oil on my second one. And you can use any kind of vinegar and oil that you have at home. I used white vinegar and I used canola oil, but you could use any kind of cooking oil, olive oil, corn oil, coconut oil, whatever you have around. Okay, so I've got my vinegar marked, my oil marked, now I'm going to mark my water. And if you don't want to mark your cups because you think you might do some other experiments with these, you can just write vinegar, oil, and water on 3 little pieces of paper and put them in front of your cups, and that'll work the same way. Okay, so now we are going to measure out half a cup of each of these liquids. Here's my vinegar. Put that in this first cup. And I'm going to put my oil in my second cup, and my water in my third cup. Now it's important when we do an experiment to keep most parts of the experiment the same. We're going to see what changes about the pumpkins, but in order to do that in a fair way, we have to have most of the parts of the experiment be the same. Those are called constants. The vinegar, the oil, and the water have the same amount for each one. It's a constant amount of half a cup. The other thing that's constant about them, they're the same temperature. They're all room temperature. So I just used room temperature water from the tap. And my oil and my vinegar weren't in the refrigerator, so they're all at the same temperature. The third thing that's going to stay the same is how long the pumpkins are going to stay in the liquids. Okay? Now, what's different? What's a variable in this experiment? What changes is what the liquids are. They're not all the same. There are 3 different ones. And we're going to see what the effect is on these candy pumpkins, which are also the same. Those are other constants when we put them in. Okay, so we're going to keep one out though. We're going to keep one pumpkin and not put it in liquid. That's going to be the pumpkin that we will compare our other pumpkins to if they start to change after being in that liquid. This is the one that looks like they all looked originally. So we call this the control in our experiment, and we're going to keep that nice and dry. Now I'm going to put one pumpkin in my vinegar. Gently, I'm not going to splash it in or throw it in. We want the water to be calm, and the other liquids to be calm too. Put one in my oil, and one in my water. Okay. Now, the other part of an experiment, besides having constants and having a variable, is to make a prediction. So you can take your data sheet and say, which liquid will do the best job of dissolving the candy pumpkin? Which liquid's going to do the best job of making that solid candy pumpkin turn into a liquid, look like a liquid? Is it going to be the vinegar, the cooking oil, or the water? So you can make a guess now, make a prediction or a hypothesis, and you can check off the one you think will do the best job, or you can put them in number order. Like, I think this one will do the best job, and this one will do second best, and this one will do third. So that's going to be your prediction on your data sheet. The next thing we're going to do is set our timer for 15 minutes. Okay? And after 15 minutes, we're not going to touch these or take them out. We're just going to look at them and see how they look. Do they look different from when we first put them in? Do they still look like this pumpkin, or do they look not so much like that pumpkin anymore? So we've also got some boxes on your data sheet to keep track of that. You're going to make some observations and write them down. You can either write a couple sentences or words about how each of these looks. I've got a box for vinegar after 15 minutes, oil after 15 minutes, and water after 15 minutes. You can make a few notes, or you can draw a picture of how the pumpkin looked in each of these cups after 15 minutes. You could even use a phone and take a picture if you wanted to. So after that 15 minutes, you're going to set your timer again for another 15 minutes. And all together, we're going to observe our pumpkins after 15 minutes, 30 minutes, 45 minutes, and 60 minutes, and see how they've changed at each stage and note it in our little boxes. Okay? Now, I'm not going to go through all that with you because that would make a very long video. And also, I would like you to see for yourself how your experiments turns out instead of just watching mine. But I do want to take a minute and show you what's happening when something sugary dissolves in water. We're just going to go over the water one for now. Because we know that these candy pumpkins are mostly sugar, and we have water as one of our, it's called a solute, the thing that, actually it's a solvent, the thing that the solute gets dissolved in. Water is our solvent, our pumpkin is our solute, and we're going to see, I've got a picture that will show us how it would look if we had a microscope and see what's happening to these sugary pumpkins once they get put in, at least in the water one. Okay, so let's do that now. Now, dissolving a solid in liquid means that the molecules of the solid, which are the tiny little particles that we can only see under a microscope, those molecules would no longer hold together and make a solid shape. They get spread out throughout the liquid. So here is, these are representations of all those little water molecules. And here's two sugar molecules, which is also called sucrose. Those are pretty big compared to the water molecules. And there's two of them stuck very tightly together because it's a solid. Okay? Now, the water actually has kind of a magnetic force associated with part of the water molecule, and that magnetic force pulls on certain parts of the sucrose molecules. Okay? It has an attraction to them and pulls them towards it. Now we can see these two sugar molecules are kind of starting to move apart. These water molecules can even insert themselves between these two sugar molecules and kind of force them apart because they're making the sugar molecules attracted to the water instead of to each other. They break that bond that these two sugar molecules have to each other, and instead the sugar molecules are going with the water that they're attracted to. And eventually they move even farther apart. They're still sugar molecules. They're still sucrose. They haven't stopped being sugar, but they've stopped bonding together to each other to make a solid. Now they're drifting apart and they're going to be in this water solution, and they're going to be liquid just like the water is. Well, how did your experiment turn out? Did your prediction come true? Did the liquid that you chose as working the best on dissolving a pumpkin do the best job on dissolving the pumpkin, or did you have a surprise? If you were surprised, do you have any theories about why your prediction didn't come true, or any changes that you would make to your prediction? If you have any pumpkin left, you can use your spoon to scoop in, take it out, and put it next to your control pumpkin, your original pumpkin, to see how many changes it had. Or if you have a partial pumpkin left, you can do the same thing with your spoon and compare it to the original pumpkin. There's lots of different ways you can change this experiment too. You can change the variables. Instead of using 3 different liquids, what if we used water, but we used 3 different temperatures? We used cold water, room temperature water, and warm water from the tap. We wouldn't need to heat the water up. Just warm water from your sink is fine. You could try that and look at them after 15, 30, 45, and 60 minutes and see if the temperature of the water makes a difference in how fast or how slowly the pumpkins dissolve. Okay? And then you can also try different liquids besides the ones we've used here and see how they do at dissolving your candy pumpkin. Or any other kind of candy. You could try hard candy, you could try different types of candy and see if they react more quickly or more slowly or more completely than the candy pumpkins did. There's lots of ways to switch this up and do different experiments. So I hope you have the opportunity to do that, and I hope you have fun doing that. And I will see you next time on Super STEAM at Home Junior Edition.